Ladies and gentlemen of geometry, welcome to the beginning of Unit 2. Starting off with something that you guys should at least be a little bit familiar with from algebra, maybe you recognize it, talking about parallel lines. So parallel lines are exactly what they sound like. So what you ought to be able to do by the time we're done here is this stuff down here. Identify all the different kinds of parallel, perpendicular, skew lines, and identify angle relationships, and then solve problems and logically justify results. So what we're looking at is just kind of basic idea of what we're parallel lines. So parallel lines are exactly what they sound like. Parallel lines are going to be right, a little bigger here. Parallel lines are going to be one, they are coplanar, but they are non-intersecting. Meaning no touching. All right, non-intersecting. That means no touching. All right, these guys are going to be this M and N. These guys are never going to touch. And one of the big key ideas here is that they are always going to be the same distance apart. Okay. Or another way to say that is going to be equidistant. So EQI. And they're going to be equidistant forever, always. They're never going to touch each other. So what happens, and I start throwing ideas in here with that. So skew lines are a little bit different, okay? Skew lines, the only reason we talk about skew lines right here is because like parallel lines, okay, they are they're going to be non-intersecting. But that is the only thing that they have in common here. Okay, they are non-intersecting. For one, skew lines are often non-coplanar. All right, and for one, and a lot of times they are not equidistant. Okay, that's equidistant, by the way. So if I'm looking at this, so kind of thinking about this in the world of, this is called a Venn diagram, so in the world of parallel and skew lines, okay, the only thing that goes in here is that they are going to be non-intersecting. That's the only thing they have in common. Okay, non-intersecting. All right, parallel are going to be coplanar. All right, this is going to be non-coplanar. All right, and this is going to be equidistant. This is going to be non-equidistant. Okay, so make sure you have that difference distinguished. Okay, non-equidistant. Okay, and this one is equidistant. That's an A, that's an N. All right, so make sure you kind of keep those straight. All right, so when we look at parallel planes, let's see if I can do this. Nope, can't do that. So let's slide that over. Slide that out of the way. Let's slide this back. So parallel planes are exactly kind of what they sound like. Parallel planes are going to be like R and P here. Parallel planes are going to be non-intersecting planes. And what's also true about them is that they are going to be equidistant as well. But it's not lines, we're talking about whole planes. Okay, so you're talking about R and P. So what happens when I have two parallel lines and then I cut them with another line? Well, the line that we talk about that cuts through the parallel lines is called a transversal. Okay, so S and V are parallel. T is your transversal. Boom, right there. So now we talk about angles that lie between the two lines. That's inside here. That's here and here. That's going to be 4, 5, and 3, and 6. All right? Exterior angles. Angles that lie outside the two lines. We're talking about out here. So that's 1, 2, 7, and 8. All right, now these angles have very, very specific relationships. Okay, so, but before I get into that, let's kind of think about a couple things here. Just a quick review, okay? A and B are vertical, as are C and D. That means that they're going to be congruent, okay? A and C are going to be a linear pair. That means they add up to 180 degrees. Okay, that part doesn't change. Okay, that doesn't go away. Now I'm just adding a little bit more to it. Okay, so I'm going to slide this out of the way, bring this back. So kind of bear that in mind through this. So now, let's start here. Consecutive interior angles. Consecutive interior angles are going to be, basically another way to say that is same side. Okay, so same side interior angles. That's 3 and 6, and that's 4 and 5. Those would be interior angles that lie on the same side of a transversal. Alternate interior angles, this guy right here is going to be going across the transversal. So you got to go across the transversal. So that'll be 3 and 5 and 4 and 6. Okay, pause if you need me to do that. All right? So non-adjacent exterior angles are going to be exactly what they sound like. Non-adjacent, so not next to each other, exterior angles. So that'd be 1 and 7, 2 and 8. Non-adjacent, not next to each other. And then corresponding is exactly what it sounds like. Corresponding just means same location. Okay, so let me erase some of this. That's not letting me do that. All right, so let's do this. So same location. So 2 and 6, 1 and 5, 3 and 7, 4 and 8. Those are all considered corresponding. All right, and you have that written right here. 1 and 5, 2 and 6, 3 and 7, 4 and 8. So perpendicular lines always form to make a 90-degree angle. All right, and like I said earlier, vertical angles to 1 and 3, 2 and 4, they are always going to be congruent. And two angles who form a linear pair, it's like 1 and 2, 2 and 3, 3 and 4, 4 and 1, all these relationships, they form a line, and they also equal 180 degrees. So bear that in mind kind of going through this. So in the following sketches, two lines are cut by a transversal or parallel. To indicate that the lines are parallel, extra arrows are put on them. So you'll see here, and then here and here. That is to allow you to recognize that those are going to be parallel. So now, fill in the measures of the other 6 angles in each sketch. So if you look, at this one, you got to use kind of what you know to figure out the rest of the angles. So if I look, so if this one's 118, well, this angle right here is vertical to that, so that's also going to be 118. All right, likewise, this is 62, that's also 62, by virtue of being vertical angles. So now, this angle and this angle make a linear pair, so that makes this 62 just by 180 minus 118. And then the fact that these two are vertical makes that 62 as well. Okay, so kind of using that same principle down here. This one is 62. These two angles together, the 62 and this angle right here, are a linear pair. So if I take 180 minus 62, I get 118. So that makes that 118, that one 118. All right, and all I did was use two ideas. The fact that they make a linear pair, that two angles make a linear pair, and that two angles are vertical. That's the only idea I used. Let's go this. So likewise, similar situation here. So if this one's 97, if I go diagonal, that one's got to be 97. This one's 83. I go diagonal, that one's 83. So these two make a linear pair. So if I take 180 minus 97, I get 83. So that makes this angle 83. Again, using vertical, that's 83. So same kind of idea here. 180 minus 83 is going to give me 97. Okay, so that makes this one 97. And then by virtue of vertical angles, that one's 97. But if you look at both of these, you should notice a pattern. You should notice something happening between here and here, here and here, and these angles here. Likewise on this one. 83, 83, 97, 97, 83, 83, 97, 97. So for all 8 angles, there's only really 2 measures going on. All right, it's kind of what you notice. So if you kind of look at your notes, we can kind of play fill in the blank here. Fill in the measures, and what you want to use down here for words is congruent or supplements. Well, 2 angles are cut by transversal, then alternate interior angles. Now remember, alternate interior angles are, I'll change it to red here. Alternate interior angles would be this one, this one, this one, and this one. All right, these 2 are alternate interior angles, these 2 are alternate interior angles. So for that one, if you look back at your notes, kind of what the situation is that those are congruent. All right, or you can use a symbol, I don't care which. All right, now if I look at the next one, alternate exterior angles, well, that's like this one, and then this one, and this one. All right, those 2 are going to be, those 2 pairs are going to be alternate exterior angles. And again, they're going to be congruent. And if 2 parallel lines are cut by a transversal end, corresponding angles, let's change up the color here. Corresponding angles, brown. Corresponding angles are in the same location. So that means this one and this one. 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 All right, again, they're going to be congruent. Now, consecutive interior. This is the last one. Consecutive interior. And this is the only one that's not congruent. Okay, so you got to pay close attention here. All right. Consecutive interior means this one and this one. It also means this one and this one. Consecutive interior, or same side interior. This is going to be the only one that is a supplement. Okay, that means that it's going to equal 180 degrees. All right, that's the only one that fits into that category. All right, so 3 of them are congruent. All right, the other one is supplementary. So when I look, you need to figure out what X is and Y because of alternate interior, exterior, corresponding consecutive interior. So if this one's 51, and I look at X and 51 are both on the interior, X and 51 are both on the same side, so this is going to be consecutive interior. That's going to be consecutive interior. I apologize for my handwriting. So consecutive interior, if you back up and look, these are supplementary. So that means X plus 51 equals 180. So one-step problem here, X equals 129. So X is going to be equal to 129 degrees. So here, 94 and 94 degrees and X degrees. Well, I'm looking, they are on opposite sides of the transversal. They are on the outside. So that's going to be alternate exterior. Alternate means opposite sides, exterior means outside. All right, so if this is 94, if you go back and look, X is also going to be 94 by alternate exterior. So if you look at number 7, looking at 2x plus 1 and 105. Well, again, they're on opposite sides. but this time they're interior, so that's going to be alternate interior angles. So that means 2x plus 1 equals 105. So 2x equals 104. So x is going to equal 52. There's my answer. Boom. So same kind of situation, taking it a step further here. A little bit tougher problems. 3x minus 6 and 81. Notice they're both on the same side and they're both below, so they're both in the same location. So that makes it corresponding. I got to be able to write better than that. That's a little better. Corresponding angles. So I want to say 3x minus 6 equals 81. So I get 3x equals 87. So I get x to be 29 because of corresponding angles. 9, taking a look. You know what? They're both on the inside. They're on opposite sides of the transversal. So I'm hoping that you recognize that as alternate interior. All right, so that's going to be this is equal to this. So if I slide this up, 8x minus 15 equals 5x plus 3. So that's going to be 3x equals 18, x equals 6. Boom, there's my answer. So last kind of situation here. Move it over to give us some room. So these lines are parallel. Let me change colors here. So these lines are parallel. This kind of acts like your transversal right here. So if you look, they're on the same side, they're both inside. So that's going to be consecutive interior. Consecutive interior angles. And this is the only one where these two together equals 180. So when I set that up, 12x plus 4 plus 5x plus 6 equals 180. So that becomes 17x plus 10 equals 180. So 17x equals 170. X is going to equal 10. All right, and that's just straight algebra stuff you've been doing for a long time. So x is going to be 10 because of consecutive interior angles. This is the one you recognize is the only one that's going to equal 180. All right, come talk to me with questions, and let's get this figured out.